here up on the board, it says, finally, brethren, whatever is true, whatever is honorable, whatever is right, whatever is pure, whatever is lovely, whatever is of good repute, if there is any excellence and if anything worthy of praise, dwell on these things. So if we're supposed to think about these things, then there are other things we're not supposed to think about. These are the things that we need to be putting in our mind from what we read and what we listen to and who we hang out with. And I think that's just a good reminder. I always said I wanted to paint this like on the wall above my TV. Because you think about all the stuff that comes on, you know, we don't watch a lot of TV, but we watch a lot of basketball games. So commercials are usually where stuff slips in. I'm like, I want to put that up there just to help us remember. It's a good verse, I think. All right, let's go ahead and pray and we'll get started. Father, thank you for this day. Lord, thank you for these students. Thank you for their families. Thank you for the sunshine coming in the window. Thank you for the nice, mild weather. Lord, I lift up the students to you this afternoon. We especially pray for Laurel, and she's got a little bit of a cough going on. I know, Lord, there's a good bit of sickness and stuff going around, and the cough can be kind of annoying. So we just pray for her, Lord, and for complete healing for her and anybody else in her family who may be ill. Lord, I pray that you would help us to use our time wisely today. I pray that what we do and what we say and what we think about will bring honor and glory to you. It's in Jesus' name I pray. Amen. Alrighty, so we today are going to kind of get back on moving forward. Did last week's kind of pause, could you tell anything? Did that help a little bit, or did y'all notice anything? What do you think? All right, Luke.
It helped.
Did it help? How did it help?
You see, the hardest thing is, my hardest thing is the negatives. I hate negatives.
You're just a positive person, aren't you, Luke?
I don't like the negatives.
Okay. So this week, did it give you a chance to kind of practice that a little bit more before we did something new? Okay, good. What about you, Isaac? Did it help you? Kind of pausing a little bit? Were you able to get caught up somewhere? Yeah. So, I hope it did. Caroline, did it give you a chance to almost get caught up?
I was caught up. I did test 5 today.
Okay.
So I'm getting there.
So which section?
The next one's going to be 25.
Okay. So you're getting pretty close then. That's good. All right. What about you, Kate? Did it help? How did it help?
I don't know.
You need a violence test.
Oh,
Sorry.
I thought you were just observing for a second. Sorry.
I'll be back to
I
just
think I
today.
have it. What did I
Just
just
kidding.
Oh, here it is, yes. I have a whole pile for that.
Thank you. I'm just sorry, guys.
Oh, no, you're fine.
Thank you.
Yes, that's all.
Okay, thank you.
You're welcome. All right, now, Kate, how did it help? It did. So when you were doing homework this week, was it a little bit easier? Okay. All right, so I'm hoping that was beneficial to everybody. We're going to go on to the next lessons, but I don't think the one we're about to do is going to be super hard for y'all. I don't think. So we're just going to try. Let's see how it goes, okay? I'm going to read a verbal expression, and I want you to write down what you hear. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. So just go ahead and number 1 through 11. And yeah, just number straight down the page, because you may need some room to the right of it to make some notes. Okay? And I want to see how well you can translate, because this skill we're going over, a lot of this is pre-algebra, but some of it's kind of tricky, I think. Okay? So we're going to make sure we've got this skill, because you're going to need it to do what I'm about to teach. Okay? It's solving the equations. All right. For number 1, I want you to write an algebraic expression, which just means a number sentence, okay, with a variable in it, for this. The sum of a number and 7. Now, we don't know what the number is, so just use n, okay, or x, or whatever variable you want to use, okay? The sum of a number and 7. That's number 1. You gotta kind of think, what does sum mean? S-U-M. Now these should all be expressions. Everything we write is going to be an expression, which means I don't want you to write an equation. What's an equation? It's going to have a what in it? Look up here. What's it going to have in it? What's this?
Equal.
An equal sign. Okay? So an equation is going to have an equal sign in it. An expression is not going to have an equal sign in it. So we're just going to write expressions. The sum of a number and 7. Here's my number. And sum means add 7. That's it. How many people had that? None of you. Oh no. Nobody wrote in plus 7? Did you write a different variable plus 7?
I wrote in plus 7.
Oh, okay. Yeah, but you didn't know the difference at that point. And that's okay. Just from here on out, you don't have to put the equals. Okay? There's no equals because they're not going to tell us what it equals. Okay, but that doesn't mean it's wrong. That's okay. All right, try this one. 7 less than a number. 7 less than a number. And I'm not talking less than. If I said, I'm 7 years less or younger than my brother, what would you do to find that age? 7 less than a number. It would be the number, what? Minus 7. There you go. All right, 3. The opposite of a number decreased by 5. The opposite of a number decreased by 5. Okay, so how do you write the opposite? It's a negative sign. The opposite of a number, so opposite in, decreased by is a subtract by. So if you miss it, just fix it, okay? When you hear decreased by, that's going to be subtracting. Number 4, listen carefully. The sum of the opposite of a number and negative 5. The sum of the opposite of a number and negative 5. Alright, looks good. The sum, so you knew it was going to be adding, of the opposite of a number and negative 5. Now your book simplified that to this. Okay? Because subtraction is the same as adding the opposite. So if you saw that in the book as the answer, you would say, well, it's the same thing, right? Okay, so we're good. Number 5, we're a little harder. Number 5, well, maybe not this one, I think y'all got this. The product of twice a number and 8. The product of twice a number and 8. All right, I see a couple different things here. Product, y'all all knew that was a multiplication, so that's good. Twice a number is going to be 2 times a number. Okay? So not a square of a number. It's going to be twice a number. 2 times a number. The product of that and 8. You could put the 8 after it, we typically put it in front of it, but it would mean the same thing. So the product of twice a number and 8. What would that simplify to if you worked it out?
8 times n times 2.
Yes. But can you simplify it? Yeah,
Oh, sorry.
No, go ahead.
16.
Yes, so you were just doing the commuting and the associating in your head. That's good. All right, let's jump up here to 6. The sum of twice a number and negative 5. The sum of twice a number and negative 5. All right, we know it's going to be a sum. We want twice a number and negative 5. Your book simplified it to this because subtraction is the same as adding the opposite. All right? 7. This one gets a little longer. 5 times the sum of twice a number and negative 5. 5 times the sum of twice a number and negative 5.
Sorry, repeat.
You want to repeat it again?
Yeah.
This one is long. 5 times the sum of twice a number and negative 5. All right, I'm going to start doing it up here. This is kind of hard. Y'all know I'm a visual person, so this would be hard for me to hear it and get it. But I think it's valuable to try. 5 times, so we know there's going to be 5 times something. The sum, so we know we're going to be adding, but we're going to have to put it in parentheses to tell them you're going to have to add it first because you're about to multiply it by 5. So you have to use parentheses. When you see 5 times the sum, it's a distributing issue, okay? 5 times the sum of twice a number and negative 5. What do you think the book would simplify that as? What do you
Minus 5.
Minus 5, because it's the same. Did anybody get this?
Yes.
Yeah, good. I thought that one was kind of hard.
I put negative, I put minus 5.
Yeah, okay, good, good. All right, 8. This one's, well, you know what, we're gonna skip it. That's a little over the top. Okay, let's do 9. The product of 7 and the sum of a number and 10. The product of 7 and the sum of a number and 10. The product of 7 and the sum of a number and 10. Did you get it? Oh, that's awesome. Good, 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 good. 10. The sum of 3 times a number and negative 4, comma, multiplied by 5. Let me read it again. The sum of 3 times a number and negative 4 multiplied by 5. The sum of 3 times a number and negative 4. Then they put that comma because they're saying that whole sum multiplied by 5. I would probably stick it in the front. The book would simplify it to this. Okay? All right, now I'm going to skip 11. We can skip 11. Now, why did I do this? Again, this is a prerequisite skill for something we're going to be doing today, and I needed to make sure y'all knew how to change those before we can do the skill. Everything we just did is in the lesson on lesson 30. So if you realize, hey, I need to kind of look over that again, it's actually written out in the book. Okay? Everything we just did. So for Laurel, who may be listening to this later, Laurel, it is on page is that? 125. All of that is on 125. All right, I want to jump to this lesson. This is lesson 30. We're not doing a quiz today since this week was kind of a review. This is example 1 from lesson 30. 32 hundredths of what number, so you put this in your notebook. 32 hundredths of what number is 24 and 32 hundredths? This would be a really good time to have a calculator. Okay? So if you have your calculator with you when you work this in a second, you're welcome to use your calculator. Because we're getting to numbers that we don't want to have to waste the time to confuse. 32 hundredths of what number is 24 and 32 hundredths? Okay, I think I told y'all 2 weeks ago we were talking about turning these into an equation. 32 hundredths, we're just gonna write 32 hundredths. What does of usually mean? Multiply. Okay, so we're gonna multiply, but it's 32 hundredths times what number? Well, we don't know, so we'll just put it in. What do we usually put for is?
Equals.
Equals. And then this. Okay, so Isaac, make sure you got the equation down, okay? Because you're gonna have to give me the question. You already got it? Okay, good. Now, let's solve that equation. Okay? Caroline, can you tell me how to solve it? I gotta get this by itself. How do I get rid of this? Good. Yes, you're exactly right. You're gonna divide it on both sides. So then you've got n equals, and Isaac's gonna help us with the calculation. What did it come out to? 76. Isaac, if I wanted to, I could check it. What would I type in my calculator to check it?
0.32 times 76.
And what should you get?
24.32.
Okay, good. So everybody can do that. Okay, we won't take the time with the computation. Let's go with example 2, and you are going to do this one. It's worded like this: what decimal part of 42 is 26 4/100? This one is a little tricky. What decimal part of 42 is 26 4/100? The book does this one kind of weird. I'm actually really happy with this one. I think they wrote this kind of weird. I don't know about y'all. This is just like saying what part. I don't know why they're putting that whole what decimal part in there. So what are we going to use for what decimal part?
X
Yeah, x in. What do we say of means?
times.
Times 42. I'm going to move the 42 to the front because we always put the number first. What do I write here?
Equals.
Equals 26 4/100. Your book is using WD, and again, we talked 2 weeks ago. That kind of makes it confusing. Kate, how do I solve this?
Do 5, 4, 2, 2, and do 7.
Excellent. All right, somebody on their calculator, tell us what we get.
0.62, I think.
Okay, I believe so too. And we could check it. We could do that times that and get it. And then for word problems for these, it might be helpful to go back and read this and make sure you got your equation right. Because if you're checking it in your equation, you're assuming that it's right. Okay, all of them in this section are dealing with that, turning a verbal expression into an algebraic expression, and then coding these into an equation and then solving them. I feel certain all 4 of y'all can solve these equations. Y'all have been doing that. So, do y'all want to ask any questions about lesson 30? Do you feel like, yeah, I got that? Okay. Yes? You good?
Yeah.
Shouldn't be a whole lot of negatives. I think you'll be okay. Okay, so let's go ahead and go to lesson 31. Okay, now I just said, oh, those little equations, y'all can do that. Okay, we're leaving little equations. We're going to go on to some bigger ones. Okay, so let's go to example 1. But before I even tell you what to write, I'm going to give you some steps. Okay, the first thing is to eliminate. You're going to want to write these down. Eliminate parentheses. I'm just going to abbreviate it and draw some parentheses. Eliminate the parentheses. How can you eliminate parentheses? You just, what do you do?
Using the distribute.
Okay, sometimes you're going to have to use the distributive property. Sometimes there may just be numbers in there you can add, subtract, or whatever it says. If it's just numbers, just do it, the arithmetic. But Luke's right, sometimes you're going to have to use the distributive property. The second step is to add like terms on both sides. I call that combine like terms on each side. And I'll show you what I mean by that in just a second. You know, put your x's together, put your y's together, put your constants, your plain old numbers together. The third thing you're going to do is eliminate x on, whoops, that doesn't say on one side. You want x on one side by itself. So you've got to eliminate x on the other side. 4 is to eliminate the constant term. What's a constant? Plain old number. Okay, it's just a number. And then the last thing you're going to do is eliminate. We need an abbreviation for eliminate. Maybe I should put E. Eliminate the coefficient of x. What's a coefficient? Anybody know what the coefficient is?
Used to.
It's not the opposite. You're brave though. Try. What'd you say?
Used to.
You used to. Okay. It's the number in front of the variable. Like if I wrote 2x plus 4, 2 is the coefficient. 4 is the what? Plain old number. It's a constant. Okay, so 4 here would be a constant, and 2 would be a coefficient. It's just the number that's being multiplied by the variable. All right, now I'm going to actually give you the problem. Here you go. 2 parentheses 3 minus b equals b minus 5. Go ahead and copy it down and lay your pencil down when you copy it, when you finish copying. If you need to stretch or get a drink of water, now's a good time while you're waiting on everybody to copy. I'm gonna be like Caroline. This is bugging me, Caroline. I just realized there's a little circle there. Okay, y'all ready? All right. According to our directions, we need to eliminate the parentheses, but I can't just take them away. So what do?
Distribute.
Distribute. That's our first step. We're gonna distribute. Ooh. 2 times 3 is 6 minus, what do I write? 2b. I have to distribute to the second term. Equals b minus 5. Okay, I just did this one. I'm going to check it off. Combine like terms on each side. So I'm going to ignore this side. Is there anything I can add and subtract over here? No, I can't subtract those. What about over here? No. Okay, done with that. Eliminate x on one side, or the variable. I could move this b, or I could move this 2b. Now watch. That minus belongs to 2b, so how could I get rid of it if I wanted to? I'd have to add 2b. Or I can come here and I could, how would I get rid of this b? I'd have to minus it. So that minus belongs to the 5. This b does not have a sign in front of it, so it's positive. I'd have to subtract it. So I have 2 options for this step. I can add 2b to both sides, or I can subtract b. Doesn't matter, either will work. Y'all got a preference?
Let's make it positive.
I'm with Isaac. When I have these, I'm gonna almost always do whatever I can do to add. Because if I subtract b, I've got a minus 2b minus a b, and I might make an error. So when I see a minus, I'm like, that's what I want to do. Let's add 2b. But either way you do it, it will come out. So show add 2b on both sides. Okay? All right, what's left on the left side of the equation?
6.
Just 6, because that all cancels. 6 equals, what's b plus 2b?
3b.
3b minus 5. We just did step 3. We eliminated x on one side. Now we're going to eliminate the constant term. Well, we have 2 constant terms. What are the 2 constants?
5 and 6.
Yes, but it's negative 5, right? Negative 5 and 6. If I get rid of this one, I'm just going to end up with 0, and then I'm going to end up with a variable and a number over here. That's not really going to help me. It's not wrong, but it's not going to help me. So I probably should get rid of this one, right? I'm going to get this by itself. So how do I get rid of minus 5?
Add 5.
Add 5. What if I subtracted 5? Would it cancel?
No. it'll be
No, because
-10.
-5 minus 5 would be a -10. So I'm going to have to do the opposite. Minus 5 plus 5 cancels. Add 5 over here, and I get 11. 11 equals 3b. Alright, then I have just eliminated the constant term. Now I'm going to eliminate the coefficient of x. What's the coefficient of the variable?
3.
The 3. How is this attached? By what operation?
Multiplication.
Multiplication. What's the opposite of that?
Divided.
Divide. We're going to divide both sides by 3. And 11/3 is my answer. In previous math classes, you would have to turn that into a decimal or turn it into a mixed number. In algebra, they don't. They leave it just like this. Because it's simpler to check this equation if you just put it back in like this. Okay? Although it would still be a pain. Now, they don't ask you to check it, and I'm grateful because can you imagine putting it in that fraction there and there and how many fractions we have to do? So I'm kind of grateful. Now, if you have a TI like Isaac does, it will do fractions for you. Have you learned how to do that on there? Remind me at the end and I'll show you how to do it. It's really helpful for a lot of things. Okay, it would straight up, you can key this in and tell it I want you to make B 11/3 and it would do that for you. Okay, and I can show you that after it'll remind me. All right, let's try an example 2. Example 2. A little bit longer, here we go. 3, parentheses, 1 plus 2x, outside of parentheses, plus 7, equals -4, parentheses, x plus 2. I want you to try it on your own. If you get stuck, look at your neighbor and say, help me. Maybe they can help me. I'm gonna walk around and look too. Very, very, very good job. Yeah, you're going to have to distribute a negative on the right side, so watch out for that. So you're on step 2, right? So combining like terms, look at this side. Is there anything in there that you can add or subtract later? You can't add 3 and 6x. You can't add 6x and 3 and 7. Yes, you can add 6. There you go. Is there anything else that you can do? Nope. So then you've done step 2. Did you get it?
I accidentally tried to do both of these things at once. I ended up doing that, but I just
That's okay, you can just move it over. All right, what did you make your final answer?
ended up 18/10.
Simplify it, and you'll have it. If you simplify it, that's it. Now simplify.
x. Eliminate x on one side. You could add 4x, yes. I would think that probably meant that's right. Okay. And then you're gonna do it on the other side with the variable. Very good. Good. Yep. Good. And it's negative, right? So leave that negative off. There you go. Perfect. So y'all are both at the same spot. What are you gonna do right there? So you've done, you did this, now you gotta get rid of the constant term. That's with the variable. So that's this guy right here. You gotta get rid of it because it's the constant, but that's with the variable. I might should put that there. Eliminate the constant term that is with the variable. Or on the same side. Maybe. Right, hold up, don't do that yet, because you gotta get the constant term first. Okay, so look, okay, you gotta eliminate the constant term and then the coefficient, two different secrets. Constant term first, so you're gonna subtract 10 from both sides. Did you subtract 10 from both sides? There you go. Well, the constant term, that's your constant. It's called a constant because its value is not gonna change. This guy's a variable because it's gonna change. So take it, there you go. You gotta take it from this side too. If you subtract 10 there, subtract 10. There you go. What'd you get right here? So you got not like 1, negative 8 minus 10. Right? You put that in. Here's your negative. Oh, negative 8 minus 10. 3 negative 18. Okay. Here's your subtract. It's already negative 8. You take 10 more, so it's negative 18. Good. Now you're down to step 5. You gotta get rid of the coefficient. So you gotta get rid of that 10. Good. Good. Now don't lose the negative. You still got a negative. That's right. Oh, well, you got divide. You got both sides. I always remember that second side. That's it. Now simplify that. They're both divisible by 2, right? So hopefully you got that x is equal to negative 18 tenths.
Oh.
And then you simplify it. Divide them both by 2, and you get negative, don't lose the negative. Whoops, I just made it not a negative. Negative 9/5. Negative 9/5 is your final answer on this. You got it. You got it. You just got it, right? And Kate just got it. Wow, that's like the first one y'all have ever done by yourselves, and that's pretty good. I feel like. That's a lot of steps, but anything on this section, every single equation in this section will be done the same way. Alright, I think we're gonna move on to make sure we get everything done, but then we're probably gonna come back and I'm gonna throw another one of those at you. I'm gonna leave the steps on the board, okay? So let's go to 32. 32 just says word problems. Now you're gonna see why I opened the lesson like I did. So for 32, here's example 1. The sum of twice a number, I'm gonna abbreviate number, and 13 is 75. You gotta find the number. We'll do it together. The sum of twice a number and 13 is 75. Find the number. The sum of twice a number and 13 is 75. I want you to write down what you think the sum of twice a number and 13 is? The sum of twice a number and 13. How would you change that to an algebraic expression? All right, the sum, hopefully you knew, I'm going to be adding, of what? Well, of twice a number and 13. The sum of twice a number and 13, and I'm not multiplying it by anything, so I don't have to put parentheses, is 75. How many people had the first part of that right? Yes? Good. So now you know why we started with that, okay? Now can you solve this? Well, those should be pretty easy to you now, because look, you don't have a step 1, you don't have a step 2, it's already done. Step 3 is already done. You're just going 4 then 5. Try this one. Okay, so again, these top 3 are done. Now we need to eliminate the constant term. There's only 2 constants. What are they?
13 and 75.
13 and 75. Not going to help me if I get this to a 0, right? I want to get rid of a constant that's with the variable. That's the 13. How do I get rid of it?
You.
Subtract it, right? Then I end up with 2n equals 62. How do I get rid of the 2? Because it says, good, eliminate the coefficient of x. It's being multiplied, so I'm going to divide both sides by 2. N is equal to 31. Then I could check on that. The sum of twice a number. What is twice this number?
62.
62. Add it to 13. 75. So I can check and make sure it works. So that is actually adding a couple different lessons together. Let me see, make sure I have plenty of time. Yeah, we can do that. All right, let's do example 2.
I don't like these problems.
What did you say, Luke?
I don't like these problems.
You don't like these problems? Why is that?
I don't like where they don't just already have it set out.
Oh yeah, you don't want them to have to make you do the equation.
You have to find out if it's adding.
Right. Okay, so here we go.
Anyone that doesn't work, do more.
Yeah. Find a number such that 13 less than, that's important, twice the number is 137. Find a number such that 13 less than twice the number is 137. Put down what you think the equation is, and then just put your pencil down. Don't try to solve it yet, because if you have the wrong equation and then you solve it, it's not gonna work, okay? All right, when you see 13 less than, okay? If I say my brother is 2 years younger than me, would you do my age minus 2, or would I do 2 minus my age?
Your age minus 2.
My age minus 2. You have to kind of switch it around and do it. So if you say 13 less than, that's a minus 13. Something minus 13. twice the number is 137. So let's check it by looking up here again. 13 less than, that's 13 less than, twice the number is 137. All right, so if your equation is wrong, fix it. Okay? 13 less than twice the number. All right, again, there's no parentheses to eliminate. There's no combining like terms. There's no putting the variable on one side. It's already there. So Caroline, tell me, what do I do first?
Wait,
Wait, what?
What do I do if I'm through step 3? What do I do for 4 up here?
Up there? Add 13.
Good, because it's the constant term with the variable. So we're going to add 13 to both sides. You are exactly right. What is that? 150?
Yes.
Sorry. Okay.
wait,
Did I mess up?
no,
Okay.
it's just the, like, I put the less than sign.
Oh, and that's a common error, is putting the less than.
I would have done the same thing.
You would have done the same thing.
Yeah.
Oh, if you wrote 13 less than twice the number? Is
Yeah,
that what you're
I
saying?
would have done the same thing.
What do you mean you would have done the same thing? The same
I
steps to
would've-
solve it?
Yeah.
Well, but you would have had,
Because like the less than, I would know that was minus.
well, if you're in your mind changing it to that, but remember the order is gonna be different, because it's not gonna be 13 in front of the 2n. You're gonna have to do 2n minus 13. Yeah. But that's okay, I mean, now you know that. When you get to those questions, you won't miss it, okay? All right, then I'm gonna do the last step, which is eliminate the coefficient of x. The coefficient of x is 2, it's being multiplied, so we're gonna divide it, and n is equal to whatever half that, 75. Uh-oh. Did you go back or forward? Oh, you got it. Okay, let's see, let me check on our time. Okay, we're doing well. All right. Let me see which one I want to do. Let's do this. Example 3. Find a number. If you don't want to write the problem, it's in the book, so you can just wait till I write it, or you can start trying to write your equation if you want. It's in the book, you could look later. Find a number such that if 5 times the number is decreased by 14, the result is twice the opposite of the number. That's a whole lot. Alright, it's okay if you don't write it, that's a lot. But look up here and see if you can write the equation on your paper. Get it? No? Find a number such that if 5 times the number, I'm going to write 5 times the number, is decreased by 14, the result, what do I write for that? Equals, good job, is twice the opposite of the number. Now, I would simplify that and say negative 2n. Let me check myself. 5 times the number is decreased by 14. The result is twice the opposite of the number. 2 times the opposite of the number. How many people got one of these down?
I got it both because at first I did that one and I changed.
Good, that's good. Luke, did you get close?
I did negative 10n
Oh, where'd you get the negative 10 in?
because I thought it was twice as much as 5n.
Oh, I see. Okay, that makes sense.
The result is twice. There's where the twice comes in. That's good to know. All right, so fix it and let's solve it. Okay? Now this one they didn't do as much. There's an air vent that blows right there in there. Christian got cold there in the last class and we were like, is he cold? But then I walked over there and I was like, oh, the air vent blows there. Feels good to me. All right, do we have parentheses to get rid of?
No.
We don't. Do we have like terms on either side? No, because we can't do that. If they both had ends, we could do it. And there's nothing we can add over here. So these steps are done. Do we have an X on both sides? A variable
Yes.
on both sides? We do. So we could add 2n to both sides or subtract 5n. But if I add 2n, it's not really helping me, is it? So I need to get this one. Or actually, you know what? I take that back. I would do that and just add myself an extra step. Or I guess you could subtract it. I don't know, I don't like subtracting. I'm gonna go this route. I'm gonna subtract 5n. Okay, that's gonna make that go away. Have to do the same thing over here. But look at this for a second. Stop and look at here. This is a negative 2n, and this is a minus 5n. If you've got your calculator, you can use it to help you. But even without the calculator, you can say, well, that's the same as what? Adding the opposite. Now you can see I just need to add those two, and it's still going to be negative. Negative 7n. Just be careful in that situation for sign errors. Okay? So we just got variables on one side, numbers on the other. There's no constant term with the variable, so it's
You
gone.
could go the other way though,
I could have gone the other way.
because you would get 0 and then you'll have to take away 14.
Yep.
But you're gonna have to get rid of 14 sometime.
Well,
Not even one.
yeah, right now all I want to do is get in by itself. So how am I going to get get in by itself?
Divided by negative 7.
Divide by negative 7, because they're multiplying by negative 7. So let's divide by negative 7. This is going to cancel. Negative 14 divided by negative 7 is what?
2.
Positive 2. So all that work for that one little number, right? Positive 2, and I'll check to make sure we got the right answer. And we did. Okay? All right, but these steps are going to help you a lot this week. And they're written in the book also. All right, let's try one more of those that I thought was kind of tricky. We're going to skip 4 because I feel like that would be definitely bad. Let's do 5. And y'all probably can do this one too. And again, you don't have to write it all. It starts off saying we get the same result. If we multiply a number by 3, or if we multiply the number by 5, and then add 2. Find the number. All right, write your equation first. We get the same result if we multiply a number by 3, or if we multiply the number by 5, and then add 2. Okay, so when you get your equation, and some of y'all have already solved it or working on it, that's okay.
if we multiply a number by 3, we get the same result, so it means it's equal, as to if we multiply the number by 5, and then add 2. Okay? Alright, so 3n equals 5n plus 2. Look at our steps. Do we have parentheses? No. Do we have like terms to combine on each side? None over there, none over there. Do we need to get rid of an x on
Yes.
one side? Yes. I would probably, what do you think?
Boolean?
Yeah, you can. You can subtract 3n, but it's going to add you one, it's going to cause one more step, and that's okay. We can do that.
You can just do negative 2 and then just realize that it's negative 2 on the other
Yeah,
side.
you can. Or I could just go straight to subtracting 5n, and I get negative 2n equals 2. And then I only have one step left.
Isn't it like, it's just rewriting the problem both ways?
Yeah, it's fine either way.
It's not really.
Yeah. It doesn't matter which way you do it. Go divide both sides by negative 2, and I get negative 1. And that is the answer. If you didn't finish solving it, go ahead and finish solving it. Try to finish it without looking up here, if you didn't get it. Or if you did, then that's okay. We're going to move on with the other. But if you didn't finish, I'm going to pause a second for you to write it. Make sure, and if you need me to go over something, we'll do it. Work it the other way and just show you that it does work. Okay, let's say instead of subtracting 5n from both sides, we subtracted 3n from both sides. What would be over here?
0.
0 equals 2n plus 2. So at that point, we'd say, well, we've got a constant with our variable. We need to get rid of it. And then we'd end up with the same thing we had. Just kind of flipped around. Doesn't matter as long as you're following the rules, which order you go in. Either way, it's going to work. Okay? All right, the next lesson is 33, and it's the last one we're doing today. You're almost free, y'all. Is today the day y'all do the game with the school?
Yeah.
Yay, that's fun. Mrs. Leo, she's your coach, right? She sent us out an email the other day about basketball, and she's like, hey, I'm doing an inventory of all the jerseys, and we're missing a bunch of shorts. Can everybody check and see if they have any shorts? So I told my son, I was like, hey, Mrs. Leo needs to make sure you don't have any. He's like, oh, I got them all in. So I emailed her back and go, we have more than shorts. We have the top and the bottom. And she was like, oh, it's fine. As long as he can wear it, he can keep that.
Is he a senior this year?
He is, yeah.
For some reason, I think he was last year.
No, he's a senior. All right, so for this lesson, you got to know a couple vocabulary terms. Do you know what a prime number is?
Oh, no. Numbers.
Can't remember.
Can't you remember?
5, maybe?
Say again. It is a special number. I think it's special. Luke, do you know?
I've remembered it yesterday. I remember remembering.
I'm gonna take a guess.
Take a guess.
Isn't it, if it's times itself, it's gonna be,
Oh, wait.
Are you thinking of square root?
I don't know.
A number,
That's okay.
A number that can
It's
only be
5
divided by 1 in itself.
So it only has 2 factors, that's right. The way you stated it as a division, totally fine. I'm gonna state it as a multiplication. It's a number that only has, or it has exactly 2 factors, okay? So let's say you might wanna write that down then. Prime numbers, what's the first prime number?
1.
It's actually not 1.
5?
Because it's 2.
It's not 5, because 1 only has 1 factor.
Sorry.
Oh, 2.
It's
So
2.
confusing.
Yeah. Yeah, because prime, one is not prime because it only has one factor. And prime numbers technically have to have two factors. So I think Isaac's finding some. The next one's 3. What about 4?
No.
Oh, wait a minute, then what would you call 4? If it's not prime, starts with a C.
Number.
It's composite. Okay, composite is if it's not a prime. That's okay. Y'all are thinking compost, I don't know, something like that. Alright, so these are your things that are not prime, except for one. One's neither. Let's see, 3, 4, 5 is prime, 6 is composite, 7 is prime, 8 is composite.
9
Is 9 prime?
No.
No, it's composite. Okay, so we can keep going. But those are your prime and composite numbers. Okay, and that is going to talk about that. What else does it talk about?
2, 3, 4, 7.
Oh, it's basically, okay, your book teaches you how to do this with repeated division. It's okay, that'll work. I'm going to show you the way I like to do it though, okay? This is, it's going to say express 80 as a product of prime factors. That's what it's going to look like when you see it in homework. Express 80 as a product of prime factors. So we know about 80, we know what products are. It's a what? What's product? Multiplication, yeah. So of prime factors, okay? We talked about what prime is. So the 8-7 book, how many of y'all did Saxon 8-7 last year? It called it, give me the prime factorization. That's how they gave the directions, okay? But all you do is you take 80 and you do a factor tree. Do you remember doing factor trees? I just need two numbers that when I multiply them together, I get 80. What do you want to use?
42.
40 and 2. Okay? Somebody else could have done 8 and 10. Okay? Somebody else could have done what's some other way to get it. Isn't it like 16 and 5 or something? Huh?
Wait, no, that's not right.
I think 16 and 5. 5 times 6 is 30. Yeah, 16 and 5. It doesn't matter how you do it. You're going to get the same answer. So let's go with Luke's 40 and 2. 2 is prime, so circle it. But 40 is not, so I can't stop there. What's 40?
Composite.
It is composite, so give me two factors.
10.
10 and 4. Are they prime?
Neither.
No, so we gotta keep going. What's 4?
2.
2 times 2, we can stop there. So we circle when we get to prime numbers. What about 10?
5 times 2.
5 times 2, and those are both prime. So if you were going to do the prime factorization or a product of prime factors, I would put them in order. 2 times 2 times 2 times 2. 2 times 2 times 2 times 2.
Or you could do 2 to the 4.
Yes, 2 to the 4 times 5. Either of these answers would be acceptable. Usually you're going to see it done like this. Let me see how they read it. They listed it like this, the top, but this is fine. Okay, I want you to notice though, if you did it the other ways, you would get exactly the same answer. Okay, it wouldn't matter how you do them. In fact, let's do one of them. Let's do this one. What's 16? 8 times 2 or 4 times 4 is fine. This one's 2 times 4. 2 times 2. And 5's already prime. So we got the same thing. 1, 2, 3, 4. It doesn't matter how you start it, as long as they equal 80, you're still going to get the same prime factorization. Okay? So that's the first part of this lesson, is prime factorization. The second part of this lesson, so we're going to put a 2 here, is more of what we just did a minute ago. This is 1 week where you're going to get a lot of practice doing what Luke does not like. And it's where they don't give you the problem and make you write it. Okay, here we go. Example, this is 3. I said 2, but it wasn't. I will skip 2. Example 3, twice a number is 42 less than negative 102. Find the number. Twice a number is 42 less than negative 102. Find the number. I made a really big negative. Don't solve it yet. Once you've written the equation, just put your pencil down. Just so I can make sure we're good. Kate, did you get an equation? Okay. I'm gonna go ahead and tell you, I don't like the way the book does this section. They make it so much harder for my brain. I tried to show y'all how to do it the way the book does, but it got me confused. So I'm gonna show you the way I do it for my little brain. If you wanna do it the big brain way, then that's totally fine. But I'm gonna show you the smaller brain way, okay? Twice a number. Or how, what do I write for that?
2n.
2n. Is, what do I write for that?
Equals.
Equals. 42 less than. Is that 42 minus or minus 42?
42.
Minus 42. Because if it's 42 less than 100, you would do 100 minus 42, wouldn't you? So if it's less than something, you have to put the 42 on the back end. Minus 42, but less than what? Negative 102. Okay? Your book says right, well, I don't even want to tell you what it says. I got so confused trying to read the way they do it. This will work. Doing it the same way you did the last ones. Just do it the same way. Okay? So if you have videos and they're trying to show you this way, if you get it, go with it. If you don't, just do it the same way. So,
Let me guess, they put the 42 on the end,
Yeah.
on the other side.
they did. Yeah. Which is fine. You can do that, but it's kind of confusing the way they explain it. It actually says write an equation that's wrong first.
And this is one step down because you have the 42 on the other side.
Exactly.
It's just complicated.
Yeah, it's more complicated. So twice a number is 42 less than negative 102. So I can go ahead and go over here and do this. Subtraction is the same as adding the opposite. So let's solve it. Negative what? 144? Oh, I left the one out. Negative 144. So I had no parentheses. I did have some like terms. I just combined. Do I need to get an x on its side by itself? No, it's already there. Do I need to eliminate a constant term that's with the variable? No, there's no constant term with the variable. Can I eliminate the coefficient of x? The 2, yes, I'm going to divide by 2. N is equal to negative, what is that, 72? I think, yeah. Okay, so I would encourage you, when you get to this section, do it the same way that I showed you on the other ones.
You said no, I didn't do that wrong. It's like 42 minus. That's wrong. But like, I did it in my head a little and got 72 as an answer. But like, I could just negate that. Because if I wrote this down wrong and then got the answer and then I realized I did that wrong, I could just negate it.
I guess, I don't know, but I would rather you learn how to do it correctly than how to adjust. Yeah.
I wouldn't, like if I just accidentally wrote it down.
Yeah, I guess so. Yeah. All right, but I would try work on it this way to see if you can get it like this. All right, all of these questions are done kind of the same way. Okay, we have just a few more minutes. I'm going to flip back to one of the bigger, uglier ones and finish with it. And when you have it right, I will dismiss you. How's that sound? Okay.
As in you guys start cleaning up the chairs.
Oh yeah, that's right. So if you get done early, you get to clean more. So there you go. All right, this is not really an example. I'm going back to lesson 31. Here is your problem to solve. Solve negative, and then there's in parentheses 4y minus 17 parentheses plus opposite of y in parentheses equals, in parentheses, 2y minus 1, parentheses, minus the opposite of y in parentheses. Now, you have a lot to clean up on both sides before you can do this problem. So I would suggest, there's our 5 minutes, I would suggest looking at your parentheses and seeing what you have to distribute. And I will walk around and look. Good. No, that's not. Oh yeah, right over here. Where'd you get that to? Oh, yeah, distribute that negative. Don't combine like terms. Hey, remember, follow these steps, okay? All right, let me do this. Everybody put your pencil down. I know it's gonna kill you because some of y'all are hot pursuit right now. But put your pencil down. Okay, look up here, and I'm just gonna do like a step or two and then turn you loose again. First thing is eliminate parentheses. So what's here? Well, there's really like a 1 there, right? We don't write it, but there is. So you're distributing that negative. Negative times this is gonna be negative 4y. This negative times this, you could write it as plus, or you could write it as minus a negative. It's going to end up being a plus 17. You can think of it right there as this is just going to change that sign. It's going to change this sign, and then it's going to change that sign. Plus negative y equals, you don't even really need these parentheses. How come?
Because it's just 2y and that's y, but it's multiplying.
Yeah, so look, there's nothing being multiplied by this. There's just one of them, there's nothing else, and then you're adding and subtracting, so you don't even need those parentheses. Subtraction's the same as what? Hold up, y'all. Adding opposite. Caroline, you gotta go. Plus y, okay? All right, do you have on your paper what I have right here? Yes. All right, what other kind of, we got rid of parentheses. We don't even really need these parentheses either, because there's nothing being multiplied by it. So we're good. Combine like terms. Let's just look on this side. What's like here?
Y.
Yes. So I would underline that and that. You borrow 4 y's, you borrow 1 more y. How many do you owe? 5. So minus 5y. Bring down the plus 17 equals, let's do the same thing on the other side. What's like terms?
Y. So we use y.
Yes. Minus the 1. Finish it from there.
I don't.
Is that a sign error?
I think like, since he there, just there.
oh, did you do, okay, right here. So you got 2y minus 1. Where'd that minus 1 go?
What I got from my head was maybe 6 plus 5 made the distributive term.
But it's not being multiplied. This is 2y minus 1, and it's minus a negative, so it's adding that. You can't distribute the y, and if you did, that'd be y times 2y, which would be 2y squared. Alright, hold up, give me like 30 seconds and I'll finish it. Check what you've got, starting here. You should have tried to get the constant away, because we've done the like terms, eliminate, oh sorry, an x on both sides. You could add 5y or subtract 3y. Who added 5y to both sides? Alright, good, I'll do that. Add 5y, add 5y. You get 17 equals 8y minus 1. At that point, what should you do?
Add 1.
Add 1. You gotta get rid of the constant that's with the variable. So 18 equals 8y. That took care of that. Now all that's left is get rid of the coefficient of the variable, which is an 8. And you get y is equal to 18/8, which is 8/4. Oh, no, it's not. It's 9/4, isn't it? Okay, 18/8 divided both by 2 is 9/4, and you can stop right there. Okay, and I'm gonna check the answer. That's right. All right, I suggest do the problem, stop, and check it. Even if you have to stop at each step and check